let's begin today. So let's start on CMSC 201. Today we're going to talk about while loops and probably some more about nested loops. So that's the topic for today. Yep. So homework 3 is out. If you haven't noticed, due on Friday, as usual. Nothing strange there. Okay. So I guess lab 3 is due tonight, right, at midnight. Okay. Yeah, I think I allowed split in the homework, so let's check that out. That's homework 4. Let's go back to homework 3. Yeah, if you notice here, it says in order to split on the hyphen, you can use myKey.split, where myKey is the string, which will give you a list of 2 split parts. So let me go over that a little bit before I go on. So for instance, I know that this is about while loops today, but let's just talk about split just for a second. So we'll teach split again Wednesday, because we're going to do a little bit of a string lecture. But instead of waiting, I'll just talk about it now again. So, and we'll talk about join and all the other things on Wednesday. So basically here, if you have a string, let's say, 555, or I guess 410. That's not it. So here's like a phone number, right? But this is as a string, right? And let's say that you want to get this into all of its constituent parts. So you want to actually split it up. So there's a nice command in Python, little function that you can call called split. Now, if you just do split, by default, split splits on white space. So I'll do an example of that. But if you stick a string into the split argument, then you'll split on that, whatever that is. So for instance here, if I put in a hyphen, and remember there's no difference between the single ticks and the double ticks for strings, so if I do this, and I call this like split number, so if I print out, say, phone number, you'll notice that nothing happens to the original string, but if we print out the split number, what you're going to notice is now this is a list of little substrings. So let's watch that happen. So let's run this program. So you see here, this is a way to split things. So for instance, in your ID code thing, where there's a single hyphen, that's how you would do it. The other way then you can access it by saying like print, say, split. Remember how you access things in a list, so to access elements in a list, you would say like split number 0, and then just to do it out of order, so that you show that there's actually something going on here, right? Let's do it like this, right? And so we expect that there'd be 3 parts, so if there aren't 3 parts, then this will be a problem, right? So basically, if instead of plugging in the phone number, I say, input, tell me your phone number, right? And I say, okay, my phone number is, 443-221-1212, or 1210. So then I hit enter. Well, so if you notice, the split takes the argument of the dash, right? So you can definitely change it. Well, let's show it splitting on another character. So for instance, and you see how this is splitting on this stuff. Now, the one thing that you might have to do in your actual homework problem is then also convert the split parts to integers, because if you notice, it'll split a string into its parts as strings. It's not going to split it as numbers. So then let's say I do another input, say, tell me your full name, and its full name is here, and then I'm just going to do full name dot split like this without any this is without any special marking inside of the, what do you call it, argument. And so by default it's just going to split on white space. So let's, so the phone number is going to be 111-111-1111. Okay, tell me your full name. Eric. Jane. Right? So that's my name. And I'm going to hit enter. And then, so you notice what it does. It's split on the spaces. But even if you did something like, Eric, and you put a bunch of spaces here, and then Jimmy, right? I don't even know how to spell my last name. There we go. And you put a bunch of spaces. So this is how it's going to work. You'll notice that it's literally splitting on white space. So it goes through this part here, and it reads through while the string is equal to white space, and it skips all of it, and then goes to the next thing, which is and then here, and then split will ignore all of this white space, and then just take the last thing. So it'll also ignore tabs and new line characters, but it's really hard on a console to put in a new line character without just hitting enter. As you can probably imagine, hitting enter will end input. But you can also split. So for instance, if I said something like, let's have a weird string, and let's say that the weird string is equal to, hello there. This string is going, well, let's put tab to have some tabs, and also some end lines, right? And so this is the weird string, and then what I'm going to do here is I'm going to print out the weird string. I always find it hard to spell weird. My brain wants to put the I first because of that silly rule. And then you do weird string dot split like this, and then you print it out, and let's just see what happens. Yeah, it's my real middle name. Okay. Let's see what happens if we just do this. I think if we split, so remember it's splitting on hyphens here, but if there's no hyphens, I think it's just going to give us back a list with a single element. Oh, it didn't like that. Oh, right, we needed multiple hyphens. Okay. Let's see. What's a good name? Benjamin, I forget what his middle name is. Franklin. Well, whatever. So, so you see how this split? And so here, basically we have hello there, and then you see how there's a new line, there's another new line, then there's two tabs, right? And so, can you work without it? I mean, you can, but don't, right? Like, literally what you need to do is take the key dot split on a hyphen, and you need to take parts equals this. I mean, I'm giving you this line of code, and you really need to do this, because otherwise, to replace this, it's going to be, like 20 lines of code, right? Or maybe not. Maybe it's only like 5 lines of code. I mean, so if you're going to split on the hyphen, I guess you could do it like this. Well, we're learning it now, aren't we? And the homework's only due on Friday. And, I will provide, so that's the one thing to say, is I will definitely provide you with if there's just like a piece of code that you have to use, like sometimes we will have just a single line of code that you're just like given for certain tasks. So even if I haven't officially taught it, which of course at this point I think I have, but yeah, I'm not sure he had a middle name. I was just trying to think of someone with a middle name. And I mean, at this point, I think this is explained way more than you need to actually handle that one line of code. So please just use it. I mean, let's just imagine you want to do it without it. So without it, what you would have to do is probably do it like this. You would probably have to say something like this. You'd have to say first part equals empty string, and then you'd say something like second part is equal to empty string, and then you would say for character in my key, and so let's make the key equal to something like 1, 2, 3, 2, 2, 4, 4, 6, 6, 7, right? Because it's 7 characters after and 3 before. You don't have to do any real input validation. Assume that they enter the key incorrectly, with no spaces there. So what we'll do is say like if C is equal to a hyphen, and of course this is all very specific code. So what we're going to do is we're going to say, we'll have to have some Boolean thing, so found equals false, not found, then set found equals true, and then what we'll do is we'll say, and so if not found, then what we'll do is we'll say first part plus equals the character, and then we'll do elif this, and then we'll do second, well no, we don't do that because we don't want to take it, so then we say else second part plus equals C. And so, okay, so what we're going to do is now we will print out the first part and the second part. And so this is the reason why I wanted to use split, is because you see that this is not, this is kind of almost a homework problem in itself. So, my name is, okay, let's see, did we actually get anything here? Did it print the first part or the second part? So if not found, did it work? Did it print? I'm not sure. I think that this thing, let's see. There we go. Oh, crap. There we go. That's a problem. Alright, so, Eric. And, yeah, so now you see that it's split it into two parts. Here's, excuse me. Here's the first part. You see that there's no hyphen anymore, right? So that's, it has actually done the splitting operation. So, anyway, as I say, I guess it's actually, so what I should say is it's not totally out of the realm of possibility to avoid split. So, you technically have all the knowledge you need to avoid using split for this problem. So, you know, if you're a purist, if you believe, truly believe, you know, then you don't have to do it. So, remember what this is called. This is called a Boolean Flag, right? Remember that a flag variable is a variable which marks basically when you find something or a condition, you know, so for instance, if you, so basically the reason why we need this is because we're very specific here, we're only looking for exactly one hyphen, and as soon as we find that hyphen, then we will stick the stuff into the rest of the parts. Anyway, okay, so let's, now that I've talked a little bit about split, let's begin on while loops. Okay, so let's go over to this thing for just a second, and let's talk about, I mean, there's not a lot of theory in while loops, but let's just talk about it for, a few seconds. So, you know how if statements work? Basically, you have an if condition, right? And then a little colon, and then you have a tab, which is 4 spaces in Python. So that's, I should talk about that. Maybe I'll talk about that in just a second. And then do this stuff if the condition is true. And then maybe you have an elif other condition, right? And then you would say, do this stuff if other condition is true. And then maybe you have an else, or, I'm just saying you can have a bunch of else ifs, right? You can have as many else ifs as you want. But in this case, I'm just going to have one because that's what I'm going to do. And so in this case, you do this if both the condition and other condition are false. Yeah, so, that's a good question. I'm going to answer you in approximately a few minutes. I don't want to talk about it right now just because I'm doing while loops, but yeah, we'll get to that. Just remind me in a few minutes. So this is how if statements work. And so you might be like, well, you're not teaching if statements, you're teaching while loops. Good point, right? So a while loop is an if statement on repeat, basically. That's how I kind of, I never really used to think about it. But when I started teaching this class, I was like, what's the best way to describe a while loop? And I realized, a while loop is really just an if statement that will just keep running as long as the condition is true. So instead of having if condition, you'll have while condition. And then you have exactly the same thing in here. Do this stuff while the condition is true. Now, of course, you might say, well, how is this different from an if statement? Well, the answer is, at the end, there's a secret little jump back to the while condition. So it takes you back from, here. That was stupid. There we go. It takes you back from there to there. So basically, there we go. Not perfect, but whatever. So the idea is that when you end a while condition, this is not a line of code, right? But whenever this tabbed in block, right, that Python recognizes as part of the while loops, yeah, I mean, so, well, so here's the thing. There is actually a while else in Python, but don't use that. Mainly because, yeah, just don't use the while else. It's actually, it's a sign that you are going and looking up weird stuff that is not part of the course. Also, it's definitely weird stuff. So, the other thing about elif is that there's nothing in while for elif. Really, the point is that while is just the if part, right? And that's actually a good thing in a sense because it simplifies the way that loops work. If you had like a while, if you had something like this, this would be pretty bad. Like, if this condition happened, you would go while this, and then maybe, like, while elif this, like, that could be really confusing. So, really, what you're talking about is just having multiple while loops, one after the other. So anyway, so there's a secret little jump back, and that's really the only thing that makes it different from an if statement, right? So, so basically a while loop is an if statement that just repeats over and over and over. So, let's do the simplest example. Let's go back so before I do any examples of while loops, let's take 2 seconds, equals like 1 minute, to explain the 4 spaces equals 1 tab thing. So Python and PyCharm specifically, and Pepe, the standard for Python, specify that you should choose either 1 tab or 4 spaces to denote a tab in Python. Now, if you need an else and a while loop, yeah, no, you can combine while statements and if statements and all that stuff. So you can have an else inside of a while loop. You can have a while loop inside of an else, or all these kinds of things. It just depends on what you need exactly. But that else won't necessarily repeat. Okay, so the point is that it specifies that you should choose either 1 tab or 4 spaces. PyCharm makes the decision for you and converts all tabs you type into 4 spaces. Now you can change this feature if you go into the settings, like if you hit Control plus Alt plus S, you can change the settings. I recommend you not changing the settings because PyCharm really likes to do this. The only thing I will say is be careful, right? If you have a tab in a file and you need that tab, and I'm not talking about a \t, I'm talking about a real tab character, then if you open it in PyCharm, PyCharm will annihilate that tab and replace it with 4 spaces. Now, why do they do this? They do this because they say it makes everything look more uniform, and if you have an equal width font, then everything should be at the same tab level. Though I don't know why a single tab character. I actually think that if the decision had been made the other way, it's probably better, because a tab character can always be read as tab, whereas 4 spaces, some programs will secretly modify 4 spaces into 3 spaces and 3 spaces back to 4 spaces. So actually, I think what the general prevailing wisdom is actually worse than the other option. But the point is that the standard thing in Python, and it's really annoying, is that basically all tabs are 4 spaces. Now, if your code runs, right, if you use Emacs and you use tabs, be careful, right? If you shift the program back and forth to Emacs and PyCharm, just be careful that the thing will actually still run, because if you've used a bunch of tabs in one and then spaces and then tabs, and you mix tabs and spaces, the real bad thing is mixing tabs and spaces. This will definitely, mixing tabs and spaces will cause syntax errors sometimes. So that's not as pleasant. So that's my whole point, is just be careful shifting back and forth. Mixing tabs and spaces is bad. So if you do all your work in PyCharm, just do all your work in PyCharm. If you do all your work in Emacs, you can do all your work in Emacs. You can do some minor edits, but just be careful that Emacs or PyCharm doesn't do any weird character formatting, because Emacs will definitely, when you hit the tab character, it puts a tab in, right? That's exactly right. This is why you always check your code on the GL server before you submit. That's right. That is 100% right. And I know that I've spent way too long talking about the 4 tabs or 4 spaces equals 1 tab thing. There was a time where you could get people into like murderous rages by, having an opinion on this question. People would be like, "Oh my God, if you think that tabs are better than spaces, then you're just, essentially Space Hitler." But I think that the answer is you gotta, whatever your current project is doing, you just have to make sure that there's no secret auto formatting that will change it to something else. And that whenever you hit tab, either a tab character happens, which is the thing you want, or 4 spaces happens, which is also the thing you want. So it is very ridiculous. It's like, I think this is possibly the worst part of Python as a language. And yeah, I mean, the good news is that no one cares about Vim versus Emacs anymore, at least to my mind, because we're all using IDEs now, right? You know, we're in the 21st century. You know, if you were coding in the late 80s, you might have that battle, but I think that's all. I think that's mostly dead now. Yeah, welcome all of you. Okay, so let's actually go back to real coding. So let's start with while loops. So let's do the most basic and most fundamental example of a while loop. So let's have an input statement that says enter your password, right? And you know, so the password, we're gonna store it, you know, is gonna be Fluffy Bunny. And so what we're gonna do is we're gonna say entered password equals input. And so what if the user doesn't enter the correct password? Well, you could do an if statement that says if password is not equal to entered password, right, then print wrong password. But this will just let them through, right? Like this just drops straight through. So maybe what you actually want is, say, a while loop that says while the password is not equal to the entered password, you say wrong password, but then you also have to do something else. Remember, so, well, let's actually not do it at first and see what happens. And let's put everything into an if false just to... So what does if false do, right? Think about that. Okay, enter the password. The password I'm going to enter is going to be robots. One of my favorite words in 201. Okay, so what's going on here? What's going on here, if you can see, is that we're getting wrong password just cycling over and over. So what's happening, right? What's happening is the entered password, oh, we've lost the bottom. There we go. So let me kill the program for just a second. What's happening here is that we enter the password here, and then it says while the password is not equal to the entered password. And so then, yeah, that's the question I was asking. But also, yes, it's what's called an infinite loop, right? So and the reason why it's an infinite loop is because you see here, it prints that the wrong password is entered, but it doesn't do anything to the password. So then when the next time it goes around, it checks the same thing against the same input. It never actually gets back up here, right? It can't get back up to this, you know, it can't get back up to this line. So what we actually need to do is copy and paste this line at the end of our while loop. And the reason why we need to do this is we need to make sure that we get a new password, you know. If we don't get the new password, then we're just going to keep going in checking the same thing. So that's basically the danger of a while loop. So that's why I usually try to teach it second, because I think while loops are definitely the more dangerous type of loop. Yep. Okay. So let's do the password. We're gonna you know, office. Nope. Fluffy. Right. Password 1. How did that not work? Right. And then of course, right, so then it just drops through and we enter the password. Oh, so the thing is that, it's a good question. And the answer is that a while loop, the good news about a while loop is that it actually doesn't take any more memory. What it's doing is it's just running through and then it jumps, and then it runs through and it jumps, and it runs through and it jumps. Most likely, there's almost no additional memory allocation for it. So an infinite loop will truly run forever. And, well, as long as the hardware keeps chugging. When we get to, is the new entered password the exit condition? Yeah, basically, right? I mean, so, yeah, you could say that. So, you might even say that password is a sentinel value. Is a sentinel value. And what a sentinel value is, it's a value that is watched for, and then either you execute code, or you break a loop or jump out of a loop when it happens, right? And so basically you're going while this password is not equal to the entered password. And so the good news about this, like, what's the advantage here? The advantage here is that this will keep the user right. This will keep the user stuck in the password screen, entering thing forever until they, give up and tell you the right password, right? So that's the point. If you try ASDF123, or you try, password 2, or you try please let me in, and then that's right. Oh no, please store passwords in plain text like this. This is definitely a good idea. So anyway, yeah, so you enter Fluffy Bunny, and then, you're in the system. So, okay. Okay, so this is a great use of a while loop, and it's actually one of the primary uses of a while loop. Let's do another thing with a while loop. So I'll tab all this in so that we're not doing passwords anymore. We do a bunch of things where we're entering stuff into lists, but what if we want to enter as many things into a list as we want? So let's say list of movies equals new list, and then we say while movie is not equal to quit. Of course, there we go. Actually, I'll hit it with a dot lower. So then what we're going to do is we're going to say, movie, or list of movies dot append into movie. So that's what we're going to do is we are going to stick in that, and then what we're going to do is we're going to input tell me. Okay. Oh, and then we need to set movie. So I'm going to do it wrong first because that's usually the right way to do it. So I'm going to do this wrong first, and then what we'll do is we'll print out the list of movies, and you'll see why this is not the right. This is why not the best way to do it. But let's just try it. So because movie's not defined. Okay. So let's set movie equal to null string. If you set movie equal to quit, this is very wrong, right? Because what it's going to do here is it's going to say, oh well, the movie is already equal to quit, and it's just going to print out an empty list and be done with us. So that's definitely wrong. So let's just send it to an empty string and see what happens. So tell me a movie. The Matrix. I don't know. Cars 2. Death to Smoochie. Great movie. Okay, and then we're going to hit quit. Predator. Yeah. I'm saving up. So notice what happened here, right? What happened here, I don't think I can type that. So, you see how all the movies got entered, but also quit did. And let's think about why that happened, right? So, why did that happen? That happened because we entered the movie here. Yeah, right, exactly. So we entered the movie here, and then we stuck it in the list, and then we jump back here and we check if it's quit, right? So here, in the space between here, we're not checking if it's quit. So here's the stupid way to do it. You could say if, movie is not equal to quit, right? But then, what's the point of this? The while loop is also checking this condition, right? So this is going to solve our problem. So let's let's use Interstellar, Fast and Furious 17, Fast and Furious 18. This time we are slightly faster. And then Predator. Okay, and then here's quit. So we'll notice that quit does not, quit is not in the list, right? So you notice that this fixed it, but it's kind of, this is not the, yeah, well, well, maybe that's 19, it's slightly more furious. We've added to the ferocity, right? Is that the adjectival form of furious? So, so the point is here that we have, if the movie is not equal to quit, then we do this. But this is not the right way to do it. Let me show you what a better way to do it is, and you can tell me if you agree or disagree. So what we're going to do is we're going to do something called priming the input. And by priming the input, I'm going to move the input statement here. And then what I'm going to do is I'm going to kill all of this off, and I'm going to stick the input statement also down here. So it's true that I'm doing the input statement twice. That's unavoidable. But I want you to think about what's happening here. So the first time we go in, we're going to input a movie, but this is before we're in the while loop, right? And so what that's doing is, and the reason why we call it priming the input, it's kind of like the analogy to priming the pump. If you've heard that phrase. Even if you haven't, it doesn't matter. So the point is that what you're doing is you get the first movie before you go into the while loop. You check if it's not equal to quit. If it is equal to quit, then what happens? So let's say we just do quit first. Then what's going to happen is it's going to say, oh, the first movie you've entered, dot lower, is equal to quit. So what it's going to do is it's going to jump over the while loop and not actually do anything in here. So, so yeah, that's what it's going to do, and then it's going to it's going to exit. So cool. But what if we enter some movies? Movie 5th. Start date. Lego movie, I guess. Bird Emic, whatever that is. I've never heard of this. New to me. So, and then maybe we'll enter a few more. The Matrix 2 and the Matrix 3. Even though I'm sure that the Matrix ended at 1. I don't think they made any more. I'm pretty sure of that. Anyway, now we're gonna quit. So what's gonna happen is, Harry Potter, sure, Harry Potter, the Chamber of Secrets. Right, there's so many Harry Potters. So now we're gonna hit quit. Well, that's the one movie that you're not allowed to like, Sammy. So I think I looked it up, and I'm not sure if there's actually a movie called Quit. I'll look it up again. I think I looked this up before in previous semesters. Because, you know, there's a movie called QI. Okay, there are some movies called Quit. There's one from 2010, one from 2015, there's a short, one from 2016. So there is a movie. Oh, it's even well rated, 8.2. I guess I shouldn't be disallowing the movie Quit then. So anyway, okay, so Get Out is close. Yeah. So okay, so we're gonna hit quit now. What happens when we hit quit? So basically we're in here. We're at this line right here. So the good news is the next thing that's gonna happen is we're gonna jump up to this while loop, and it's gonna check the condition. So it's not gonna stick it into the list of movies. So that's a good thing. Yeah, that's a fun movie. Okay. Alright, so there we go. So that's a list of things, right? And so basically the point is here that if you ever need to do something like this, where you have to enter something, and you want to keep entering things until you hit some kind of sentinel value, like for instance quit or exit or whatever, then priming the input is the way to do it, and then you stick the next input statement at the end. remember, if you don't stick the, if you don't put this here, that's infinite loop time. And for whoever asked that question, this loop won't run forever. Because yes, now at this point you are sticking something into a list. So you will eventually run out of RAM, right? If your amount of RAM is finite, eventually this loop will add up. This is basically just eating up one more blob of memory every time it goes through, so eventually it will die. So that's actually a good thing, but, okay. So, okay. Let's do another example. So, this is a big topic, so this is a big fact, I guess. So, while loops are more powerful than for loops. And of course, when I say that, oh well, no. You see here, if you don't put this line in, then you're just going to put the same movie into the list over and over. Now, it's technically possible that you could enter in movies infinitely, and then you would also run out of RAM. But you'd probably run out of movies first before you ran out of RAM. So definitely run out of movies first if you only put in movies once. But if you don't have the input statement, then you're going to run out of RAM. So what do I mean by while loops are more powerful than for loops? So what I mean by that is that everything you can do with a for loop, you can do with a while loop. And let me show you that. So basically all I have to do to prove this, all I need to do is construct a while loop that does the for loop type of thing, right, in general. And so here's how to do it. So if you have a for loop that says like for I in range len list of movies, right, and then say we do print list of movies like I or something, right, who cares what's going on in here, but it's a line of code. And so really what we want to do is we want to replicate this functionality here. Functionality. There we go. So we want to replicate the functionality. So how do we replicate this functionality? Basically, the answer is that what we do is we set I equal to 0 to start, right? And then what we're going to do is we're going to go while I is less than the length of the list of movies. You should definitely take note of this. This is an extremely important part of understanding while loops. So, okay, so basically here, then I'm going to copy the same code, right? This is the whatever code, right? And end of whatever code, right? And so then what you do, so this is, as it's written, is an infinite loop, because you see that I is going to equal to 0, and then it's going to cycle forever, right? It's never going to end, and the reason why it's never going to end is you never actually do anything with I. So what is the for loop doing for you, right? The for loop is checking to make sure that your I is in this range, right? That's what the range object does for you, right? It's trying to check to make sure this, but also whenever you come back to the for line, it adds 1 to I and then rechecks, right? So we need to add 1 to I to make sure that this works. So I'm just going to do I plus equal to 1. Remember that this is the same thing as doing I is equal to I plus 1. Yeah. Sadly, we can't do I plus plus because Python doesn't have the plus plus operator. But we can do plus equals 1. I know it is very sad. It's sad that we don't have this operator because we feel, for people who've done C++ and Java, you feel so attached to the plus plus. Anyway, so basically this piece here, this bit of code here is going to do exactly what a for loop does, right? because it's going to start at the first movie. So let's do this again. And let's say that we have, what are we going to do? So we're going to say, John Wick. And then there's John Wick 2. Isn't there a John Wick 3? And then, Harry Potter and the Philosophers. So, and that's what they called it in England. And then there's Blade Runner. And then there's Wall-E. And then there's The Hobbit. The first one. James Bond. James Bond. What's a good one? Oh god, I guess I can't say half of them. Something like that. Okay. Maze Runner, sure. So, okay. Now, and now what we're going to do is quit, right? That's our favorite word. Lord of the Rings, Fellowship of the Ring. Yeah. The Bourne Legacy, I like that. Okay, so, Casino Royale, that's definitely a good one. So, alright, let's hit enter. So, okay, let's see what just happened. So Maze Runner is the last one, so where is it? Here it is. So, it's going through the list the first time. Here's the for loop doing it. And then here's the while loop doing it. Right, so basically, the for loop and the while loop are doing the same piece of functionality. And so, in general, when you are doing this kind of operation, scanning through a list, use a for loop 99% of the time. Okay? But you can use a while loop for it if you're in a bind. So there's some reasons why you might want to use a for loop or a while loop, and so basically here's one of the ways that you might want to do something with a while loop. So let's so we can do something like this. If input, right, skip or nah, then we're going to do I plus equals 2, else I plus equals 1. And so, alright, let's do this again. Born. What's another type of movie? Everybody loved The Notebook, though. I never saw it. Oh, here's a great movie that almost no one ever saw. Moon. Red's good. I like that. It's a good movie. Single name movies. Okay, I'm on. Okay. Yeah. Click split. Bird Box Joker. Sure. The Mummy. Sure. It has an article, but whatever. Life. Sure. Okay, cool. So now what we're going to do is we're going to quit. And so here what we're going to do is we're going to look at the list, right? We have a long list, and I intentionally did a long list so we can do some skipping. So let's skip. And so you notice that what it did was it skipped over this next movie, and so here we're going to say nah, and then skip, right? So let's look at red. Godzilla's in the way, but here we go to the next one. So this is an example of a while loop that's kind of, you can do skip, nah, skip, right, skip, there we go. Something like that, right? And so here, you might say, is there a way to do this with for loops? The answer is maybe, right? Maybe, but this is probably best done with a while loop. And the reason why is because the for loop is actually doing this addition for you, right? It's actually adding 1 to index for you. Now you could always do, like, you know, you start at 0, go to the length, and you could set the step to 2, but then the step is fixed at 2, right? So, and here we're doing a variable step, right? We're stepping either 0 or either 1 or 2 and based on user input. And so it's very difficult to be able to tell beforehand whether or not you're going to go 1 or 2 because the user hasn't put anything in yet. So that's kind of the this is a use of a while loop that's kind of like a for loop, but you might end up doing it as a while loop. So this is kind of, I think this is a good justification for using a while loop in this particular case. Of course, you might say, but that is kind of a weird case. I don't know why you'd want to do that. Sure. Okay. Whatever. Point is, that's what we're doing. So, okay. So here's another example of using a while loop. So let's put all this stuff into storage in that if false condition, right? You notice it's yelling at me here. It says this code is unreachable, right? Why does it say that? Because it's all under an if false. When I upload this, I'm going to take off the if false, but basically I'm just putting on the if false to basically turn off that code, right? What it's doing is it's saying if the condition is true, but then I just plug in the keyword false. So this condition will never be true. So PyCharm actually detects that the code is unreachable. There's nothing really wrong with that, except for the fact it's just never going to run. So you probably never do that in real life, but it's just a good way to turn off code. So, okay. So yeah, let's do another thing with while loops. So here's, let's do a number guesser. This was actually this was a homework problem, sort of. So what I'm going to do is I'm going to do something forbidden. So you can't really do this yet, but you also have no reason to do this until we tell you to do it. So I'm going to import random, and then I'm going to take the number is equal to random.randint, let's say 1 to 100. So what we're going to do is we're going to get ourselves a random number between 1 and 100. So I mean, you can do this all you want, but it's not going to help you with the current homework. So just wait until we tell you to do it before you actually do it, because this is, you know, currently it's not doing anything for you. Okay, so this is just going to give me a random number so that I don't know what number we're going to actually have. Yeah. So okay, so let's say input int input tell me a number. Oh, you meant the if thing. Maybe? Tell me a number, right? And so here's the guess. And so we're going to go while guess is not equal to the number, right? This is kind of like a password program. It's almost the same. But then we're going to have like an if statement in here. So let's say if guess is less than the number, we'll print out go higher. Elif guess is, say, bigger than the number, we'll say print go lower. And then here, we'll just input another guess. So remember, we're priming the input here. And here we're using a little if statement to tell the user what's going on. So they have to guess a number between 1 and 100, but we're going to give them a hint. Okay? And the hint is basically if they're too high or too low. So let's try, say, 50. Go higher, so let's try 75. Okay. All right, so why did this fail? This failed because when I was going to do it, I hit 7.5, and then as I was dragging my finger over, it put the extra period in here. Int casting from a string is very strict. Even though you might say, well, 75 dot is just the significant digit of 75, it should accept it. Python does not. So Python will yell at you. So let's try this again. 50, go higher. Let's try 75 without a period. Go higher. 87, say. Go higher. 95. Go lower. Okay, 92. Go lower. 89. Go higher. Well, there's only 2 numbers. Let's guess it's 91. Go lower. 90. Okay. That's a good question. What if we did that? So let's try float on the string 75 dot. I think it might work. Yep, it worked because it didn't crash. Yeah. So, okay, so let's do it again. And let's just go through and look and see what's happening. So let's try 50. Go lower. So let's try again. Let's do 25. Go lower. 12. Go lower. 6. Go higher. Try 9. Go lower. Now we just have 7 and 8. Well, yeah, 42. Go lower. 7. Go higher. Always miss the last one. 8. Okay. And so you might ask the question, why does this have to be a while loop? Why can't we do a for loop? And the answer is, why can't this be a for loop? And the answer is because you don't know how many guesses. So that's exactly what I was doing, right? If you noticed. Yes. Yes. So you notice here, I did 50, and then 25, and then 12, and then 6, and then it tells me to go higher, so I go halfway back up to 9, and then I do 48 because it's a meme, 42 because it's a meme, sorry, and then then here, there's no way to know between 7 and 8, right? No, but what you're talking about is actually what's called binary searching. So yeah, it's a good search technique because it we'll learn later in the semester about binary searches that take a logarithmic number of steps, right? So the answer is because you don't know how many guesses the user will take, right? So for instance, we could be a user who doesn't do that, and they starts off at say 1 and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 14. Let's try 50. Okay, 51, 52, 53, 54, 55, right? You could keep going like this forever. And we, this is like a linear search, right? Where we're just searching all the numbers possible. Let's see, 70, okay, 80. I'm too bored. Just pretend I entered all the numbers. 90. Oh, and that was it. 90 was actually the number. Okay. Yeah, that's why I got bored. Sorry. But the point is you could really do a suboptimal search, and you could just, sit here for literally, infinite, well, not literally infinite, but some large finite amount of time. So the answer is because you don't know how many guesses the user will take. So for instance, so what are the kind of applications that you're going to use for a while loop? You use while loops for GUI programs. Basically, you say while a message comes in, do some processing. Maybe for server programs, while the server keeps is running, do the following things. But for this class, the types of things, one of the most important things for this class is games, because basically it'll be like while someone didn't win, right? That's one of the things you're going to do for, and then the other thing is input validation. So, GUI programs, graphical user interfaces. So for instance, if you, here it is. So let's just do something in here. So let's see. So for instance, this main loop function in myTK is a while loop. So let's see. And so basically this is just making a little window like this. And so so graphical user interfaces programs like tk-enter, well, tk-enter comes natively with Python for some reason. There are much better programs to use, but this is just something that I could do. Well, I wish that, yeah, not to say that this is totally forbidden stuff. The reason why this is all forbidden right now is because on GL, graphics don't work, right? Because you have a text shell, and so there's no Windows graphics, anything like that. So yeah, so don't use any of this, obviously. But this is just an example of how while loops come into like GUI programming and stuff. So the more important things for us are games and input validation, because in a game, for instance, you know, you might have to scan through and say, well, while someone didn't win, right? And so that's one of the most important things. And input validation. So what is input validation? Input validation is kind of what we've been doing. Doing with the passwords and stuff like that. But let me show you kind of what I mean. So what I don't mean by input validation is type validation. What I do mean is, I mean specifically that we're going to talk about input validation for correct values within a type. And so what do I mean by that? What I mean is that, you know, if you do an input and I say, tell me an integer, right? And let's say that we say, tell me a positive integer. And we say pos int equals this. Currently, you don't have any way, and for the vast majority of this class, you're not going to have any way to determine if this is an int before it goes in here. So you're going to just have to trust us. We're not going to break your code intentionally. Okay? So if you ask for an integer, you'll get an integer. Okay? So, but, for instance, you know, if we print out the positive integer, if you say enter, whoops. Let's do this again. So, okay, so it took -5, so that's no good, right? So maybe we'll say while pos int is less than or equal to 0, right? Because I guess 0 is not positive, so we'll make sure that it does this. So while positive int is less than or equal to 0, or technically you could say while not pos int bigger than 0, right? You could do both of those. You could say something like, that was not positive. Please try again. Right? Tell me a positive integer. So here we'll say like -2, 0, -1, -15, -17, 29. And then finally the user is like, oh, well, let's try 3. And then 3 works. So if we ever restrict input, right? So this is totally within your wheelhouse now. This is something that you can do starting now, is if you need, so for instance, maybe not on homework 3 with for loops only, but by homework 4, when we allow you to do while loops, the point is that you will be able to use this kind of thing. So if I say something like, for example, enter a size of a grid, right? And then user enters -45 and -2. You should not allow that, right? So I don't know how you should. Oh, is it and positive? Yeah. So there we go. I think I typed in tell me an integer and then I put in positive in there. So it's too bad that PyCharm doesn't fix those things. So okay. So you should not generally allow that. And the reason why you don't want to allow that is because most of the time your code may actually break with garbage input, right? And so it's always good to think, like, how am I going to prevent the relatively, relatively insane user who is basically going to hammer keys hammers keys at random. Thankfully, they're always going to put in the right type, but they're, the user of any program is basically a chaos agent, right? So how am I going to prevent the relatively chaotic, insane, whatever user who's hammering keys at random from breaking, my code, right? And so it's always important to think about this because if you, the thing is that it's so easy, even as a decent user, to enter garbage input into something and then just hit enter, right? And so it's always better if it catches that and makes you re-input the thing rather than just going through the rest of the code and failing. So that's kind of the philosophy there. Okay, so yeah, and then there's what's some other input validation? Is there an absolute value function? Yeah, sure. I mean, we don't really have any use for it currently, but there's an ABS function in Python, which is the absolute value. So the question is always, like, should you just fix the user input, like just take the absolute value? No, you don't need to import math for abs. So that's one thing that's not in the math package for some reason. It's just out in the open. But the point is that, yeah, so there's no, what should I say? Do you fix the input for the user? And that is a philosophy question, basically. I say generally, in this class, you don't fix input for the user. Just reprompt. Maybe in the business world, maybe out there, you'll work for some company that's like, oh, if they enter something slightly wrong, we should add some code that reformats their input. Yeah. So, as I say, if the user enters the wrong type, your program is permitted to die, right? So, for instance, if you say, tell me a positive integer, and I'm like, positive integer, right? You're going to get a value error. And the reason why you're going to get a value error is because it tried to convert literally the string positive integer into an integer, and that's not going to work, right? It's just going to fail. There are ways to fix this. There are ways to deal with this. But let's not even worry about it, right? Because as I say, currently, right, we are not going to do anything about it. So this is like the value error is the correct result for this. If you catch the error, then we're gonna have to yell at you for using forbidden arts. Okay? So don't try to catch the error, just let your program explode. It's fine. Okay. All right. Let's see. Is there one last example of a while loop? guess you could always, well, I don't have time to present that example. I like to do, there's an approximation example I like to do. And the approximation is that I think that you could, God, I'm going to embarrass myself here. I think that 1/2 times, what is it? an plus 2 over, or x over an is the approximation, so an plus 1. I think this is the approximation of the square root. So this is a sequence that gives us the square root. So for instance, if we say float input, tell me a number, I think I can do it quickly, to take the square root of. And so we're going to take a number. And so what we're going to do, well, most of this stuff is allowed. The only thing that's not allowed is, in this file, is the importing of random. That's the only thing you can't do. The GUI stuff, I put that in a separate file. I quarantined it. I'm not going to upload it until we do the GUI lecture. So, and so we'll do current minus previous is less than, say, 0.0001. Yeah. So, okay, let's see if current equals, so previous equals current. And then we're going to do current is equal to, what? 0.5 times current plus a number over current. I think that should do it. I could be wrong, because normally I have this written down so that I don't make an idiot out of myself, but okay, so we're going to try to approximate this. Oh no, this is totally allowed. This is 100% legal. Also cool. Very cool. Very legal. No. So this is. I know that you can also just. So if you actually want to take a square root of a number, so to actually square root a number, you just do x to the 1/2 power. Okay. But here, I'm doing something different. I'm just using a while loop to get an approximation of the square root. So, and then at the very end, we can print current and say a number to the 1/2 power, and just see how close we were. So it's going while the current minus previous is bigger than 0.001. So, okay. Guess what the answer is. Okay, so let's see here. Cool. All right, so let's say we want to take the square root of 2, and I'm going to guess 1.5. Nah, this is totally illegal. What's illegal about it? Nothing's illegal about it. It's just a little complicated because there's math involved, but we would tell you the math. Huh, wonderful. Okay, let's try this again. Didn't define it, so let's do this, and let's guess that our guess is 2. Division by 0. Oh, crap. Ha. Of course. There we go. Cool. That didn't work. What's the problem here? Current equals 1. Well, this is bigger than this, so it should have done it. An plus L over An. So this is the correct square root because we're computing it this way. While the current minus previous is... Oh, I guess with the end... Oh, God, I need to... Something like this. Okay, let's try this again. Let's guess the answer starts at 1. Okay, here we are. So, if we guess that the answer starts at 1, then the current guess... So what happens is it'll go through the while loop and it'll say the current guess is 10.05 for whatever reason. Then we'll get this guess, then this guess, then this guess, then this, then this, then this, then this. And so you see that it's not exactly right. Though it's pretty close, it only differs. Does it only differ in the last digit? Okay, because we're only asking that the approximation be this accurate or better. But I guess it just kind of accidented on the something very close to the right answer. So the point here is that this little piece of code value here is the correct result for this. Oh, what I meant is if you catch it using try except, right? So if you're like, what's try except? That's my point. It's forbidden. If you catch it, don't do that. Just let the errors happen. So here you basically notice that here we input a number, here we input the first guess. I guess we could always just make the first guess equal to like 100, but then of course it would be bad if it's actually correct. So something like that. Okay. So this is another use of a while loop, and we're not going to really. This is an example that I think a lot of people don't like in previous semesters, and the only reason why I talk about this example is because it's a good one that shows. It shows that we don't know how long this approximation technique is going to run, right? You don't know how many steps it's going to take to get within the correct accuracy. So what you do is you just say, while the accuracy isn't satisfied, keep going, right? And so that's a perfect job for a while loop, okay? It'd be very hard to know, like, it's almost impossible to know how many times you need to run it. So a for loop is not really the right answer. And by not really the right answer, I mean is almost certainly the very wrong answer. So there are cases in which you need to use a while loop. And so the answer to when are you using a while loop is almost always, the real answer is always, I don't know how many times the thing is going to run. Right? Or generally, I want it to run while some condition is true. That's more general, and that's actually the definition of a while loop. But the more kind of whenever you ask yourself, do I want a for loop or a while loop? The answer is, if I have a list and I can get the length of it, then that's how many times the thing is going to run. I don't have to know the length of the list, but I know that the length of the list is the number of times it's going to run. And then Python can handle it from there. But if I don't know the length of a list, or I don't know anything, and I just say I need to run something as many times as it takes for an approximation to get within a certain range, that's a while loop. If I need to run it while user input is, not correct, that's a while loop. If I need to run it while a password is incorrect, that's a while loop, right? So that's kind of where while loops come in. And of course, the last thing I'll say is, of course, the big danger is infinite loops, right? So we'll talk a bit more about while loops next time, and we'll talk about the string operations that I haven't taught yet. So we'll go over split again, and then we'll go over strip and join, and those are it for next time. Okay. I think that's it for today. I know I've spent more time than I should have, but that's fine, I guess. Okay. So I will see you guys around. I will be, on Discord and all that stuff, so. Alright. Talk to you later.